Hello, Cal Ed. Let's wait till everybody joins up, or at least wait till a good majority of people show up. Sorry about Monday, guys. By the way, I've got all of the tests graded for this class, for the 2:30 to 4 class, and I've applied a curve, although it wasn't a very big curve. Most of you did really good. In fact, the people that are logging in right now, you guys all did pretty well.
Part of your job.
Are you talking there, Ruby, or is that something in the background?
It's in the background.
Okay. You guys can turn your video on if you want. I was experimenting around with using a virtual background, but I can't on my laptop. I guess it doesn't have enough power. So let's wait a little bit more. Actually, I'm going to get a little drink real quick. Oh, wait, I got a drink right here. Are you guys all surviving okay? We're shut down till May 4th, according to Lena Hidalgo, or actually according to the governor. We're shut down until May 4th. So I don't think we're going to be going, like I said before, I don't think we're going to be going back to school this semester. Furthermore, I got an email from the department chair yesterday saying any summer classes that you have, that you will be teaching, do you plan on teaching them online or teaching them in the building? Is there a problem with subnetting because it gave you a 0? Maybe there's a problem. I'll go check it out, Colette. Don't stress too much. If you do the subnetting assignment, turn in and get a 0 or a 50 or a terrible grade, I'm going and I'm individually looking at all of those, okay? So don't want you to worry about it. I'll point out if you're pretty sure you did a good job on it, and you probably did. But I'll go check it out. Maybe it didn't like your font. It should work. How you doing, Ella? If you guys, by the way, okay, so anyway, what I was saying was that the department chair is basically asking us, are we comfortable with teaching our classes online this summer? Hopefully he's just planning ahead. Hopefully we are not shut down for the summertime. Hopefully we can have face-to-face classes, but we'll see. Okay, so as I said earlier, there's a few more people coming in. All of the grades for up to, not including the subnetting assignment yet, are posted. If there's a grade that you don't agree with, you got a 0 or 50% or something on it, and you're certain you participated in that, like the cable making or the access in the EI lab, send me an email with some sort of proof that you participated in that. Maybe you just didn't, maybe you participated and you just didn't submit the assignment as you were supposed to do. Or if you actually did miss it, we're going to have to do something to make up for that. Like if you missed the cable assignment, that's okay if you missed the cable assignment, but you got to do something to make up for that. Since you can't very well come to my office and make a cable right now, we're going to have to use something else to fill in that space. But I'll find something good for you. All right, I had intended to make a video, and I'm still going to do this. What I'm going to do is make a video of chapter 8, the backbone network chapter. We were into chapter 8 already, but I spent a considerable amount of time making a subnetting video. Did you guys notice I uploaded a subnetting video? Did anybody get a chance to look at that video yet? Okay, was the video, when I first uploaded it, it looks like it's not in very high definition. Is it still usable, Khaled? Okay, so it looked okay to you. Maybe it just looked bad because it hadn't processed a high def version. Somebody did point out that I made a mistake on the broadcast address. On one, I think I typed in a 192. Of course, it's supposed to be a 191. Broadcast addresses are almost never even. So I may have made that mistake there, and I probably went back and fixed it, but if I didn't, I apologize. So what we're going to do is I'm going to record Chapter 8 offline so that you can go through a full Chapter 8 session from beginning to end on backbone networks. Okay, but I'm going to go ahead and start talking about Chapter 9 today. So let me get Chapter 9 pulled up here, and I'll share my screen in a minute. And this will be the last chapter before I make available an exam that is going to have some subnetting on it, but I want everybody to submit the subnetting assignment first, and let me grade them all first before I make exam number 2 available. There are study notes already up there for exam number 2. But again, I want you to concentrate mostly on the subnetting right now. So that was my first YouTube video I uploaded today. Didn't edit it at all. I'm sure it was very ugly looking. But of course, I'm more interested in content and not so much in the how pretty it looks. Okay, trying to get this PowerPoint open here. Minimize all this junk. Can you guys see my screen okay? Okay. It's going a little slow because I'm actually uploading a video in the background at the same time here. Okay, so you guys can all see that, right? Okay, so Chapter 9 is wide area networking. So let's talk about WANs, or wide area networking. Now, you guys probably consider wide area networking as the internet, because that's what's labeled on the back of a lot of your home modems, but it's not really always the internet. For most large companies, a WAN could be a network that they own and that they control, and that is dedicated for them to connect 2 or more long distance locations together. The W stands for wide. So in many situations, companies are using what's called a dedicated circuit network. It's dedicated at layer 2. They're not sharing it with anybody else. Then there's a next level up called packet switch networking, which still works at layer 2. And then we have VPN, which is what most small to medium-sized companies and individuals like employees or students are using, which uses layer 3, layer 3 and above, to make it look like you're on a local network, but you're actually on a wide area network. You're outside of your enterprise. And we'll talk about WAN design practices. So first of all, the definition of a wide area network. This is running long distances, and there's not a specific scope, by the way, but typically if you want to understand what a scope of a WAN is, it is your connection from your main location or your location where you happen to physically be, either a building or a campus like University of Houston, to another geographical distant location. Could be 1 mile, could be 5 miles, could be 500 miles, could be 5 million miles as soon as we start doing wide area networking to Mars and space stations, but that's a little ways off still. You could have a WAN, by the way, inside one room as an experiment, but typically we're talking about connecting geographically distant locations. They're separated by some geographic obstacle. Organizations typically don't own all of the land on the WAN that they're running. They're leasing it. Almost no organizations own their own WAN. So that's another important distinction. Most organizations own their own lands. Most organizations also own all or most of their backbone networks, which connect different buildings together at a location, but almost none of them own their own WANs. They are leasing or renting circuits from what are called common carriers. Make sure you memorize that term, common carrier. Can you guys all see that? Common carrier. Common carriers are companies that specialize in providing WAN services to other businesses like AT&T, Sprint, Verizon, Comcast, Xfinity, BT. What does BT stand for? Anybody know? British Telecom, Telefonica, Level 3, which is a very big network that a lot of you probably never heard of, but it carries a lot of your telephone traffic, even your cellular traffic. Tata, anybody heard of Tata? Anybody here from India? So Tata is a big network in India. They're kind of like the AT&T of India. And then there's a couple of other big ones in India. Not from India, but you visit often. They're also on lockdown for 3 weeks, by the way. The Prime Minister of India locked them down for 3 weeks as well. So anyway, Tata Communications. So just understand that a common carrier's backbone network that they build when they connect Houston to Dallas to New York to wherever they're connecting, they own that network. That's their backbone from their point of view. From your point of view, that's possibly a WAN connection or an internet connection that you're either leasing space on or borrowing or using space on. So common carrier services or common services that they provide are dedicated circuit networks, packet switch networks, or VPNs. Dedicated circuit networks. This is where we're using circuits from common carriers. We either call them leased lines or private lines, and we're creating what's called point-to-point links. This is where that protocol, and we haven't talked about this much, but there's a protocol called PPP, point-to-point protocol. Some of you typed that in on your test as a data link layer protocol, something other than Ethernet. Point-to-point protocol is a similar protocol to Ethernet. It's designed a little bit differently. It's designed with wide area networks in mind to deal with things like latency, because a lot of times WANs span many, many miles. And so if you were to be running the Ethernet protocol, sending packets back and forth, sending frames back and forth over many, many miles, your latency might be very high, because you're doing that error checking back and forth, that acknowledgement of every frame back and forth. So PPP is more efficient on long distances. Carriers install circuits that connect those two locations together. So let's say, for example, a company had an office in Houston and an office in Dallas, and they wanted to connect those two together at layer 2, not layer 3, but layer 2. And this is in part why these kind of lease lines are less popular, less common anymore. So they call up a common carrier. If that common carrier has a point of presence, or what's called a POP, P-O-P, point of presence, in both of those cities, somewhere physically close to those two locations of that company, then they can provide them a WAN connection. They literally physically run a cable there. So that's why AT&T provides a lot of WAN connections, because they got a lot of wires everywhere. Connect up special modems. We just call them modems, but the real term for them is a CSU, DSU. We call it a modem. It's not really a modem. It's a protocol converter. And it transmits frames, not packets, but frames at layer 2, not layer 3. There's some advantages to doing it with layer 2. It's a very secure network. And there's also additional protocols that you could run, additional network layer protocols that you could run if you wanted to at layer 2. When you sign up for these contracts, they're usually very long-term contracts, 3 to 5 years or longer. They're usually very expensive contracts. One of the reasons why companies sign these long-term expensive contracts is because the throughput is guaranteed. So if I say to AT&T, I want a 10 megabit dedicated leased line from Houston to Dallas for my WAN traffic to connect my 2 offices together, it's guaranteed that that is it's like building a private freeway just for you, or a private tollway just for your company's cars to use. And you can put whatever cars you want on there. We don't care. You know, cars, trucks, bicycles, you can walk, whatever. You can have any kind of medium you want or any kind of network traffic you want on this layer 2 network. And there's going to be no other company's traffic on that network. So 1, it's very secure. 2, you're never going to have bandwidth issues because some other company is sharing your bandwidth. It's not shared, so your throughput is guaranteed. Right now, a lot of you are probably getting your internet from Comcast or Xfinity, I should say, or AT&T, and supposedly you have a 50 megabit connection or 100 megabit connection or even a gigabit connection. But that 1, that's shared, and 2, it's not guaranteed. That's why you can get away with paying $100 a month for a 50 megabit connection. But a 50 megabit leased line connection can cost $500 to $1,000 a month. And that's just, and you specify 2 different endpoints. You have to have at least 2 different endpoints, or it's not a dedicated circuit. It's just simply an internet connection. So think about that in terms of what a dedicated WAN network is. There's 2 endpoints, not just an internet connection where it's just, hey, I want to connect my company at some amount of megabits per second to the internet and all the traffic shared, and it's layer 3. This is layer 2. There's at least 2 endpoints. You can have multiple endpoints. You can have 2 or more. You can set up your WAN connections in a ring or a star. This is an older technology that still operates at layer 2. Oh, excuse me. That's what a dedicated circuit networks looks like. There's another slide that looks similar to this. The common carrier network here. Let's say that's AT&T. And then these are the different cities throughout the country that I want to physically connect together. There's different topologies that we can use in a dedicated circuit network. Star topology is what we use typically on LANs because that makes the most sense. We don't use bus topology anymore on LANs. Star topologies make the shortest hops. But star topologies are not always the best kind of WAN connections. Let's take a look at these different topologies. Here's a ring WAN network, a WAN that we've set up between these different cities. We're going to assume in this example that Toronto is our home office. And then we've got offices in all these other major cities in North America. So we call up AT&T or whatever the prevailing carrier is that has service in each of these cities. And we say we want a point-to-point WAN leased line connection at layer 2 from Toronto to Vancouver to San Francisco, LA, Dallas, Atlanta, New York, and then back to Toronto. We've created a ring. This is actually not the most common, but it's the most widely suggested by WAN carriers. This is actually the most common. A star topology, which looks just like a LAN topology, where you run all of your WAN connections back to your home base. This makes logical sense, and usually most WANs grow this way because a lot of companies have a home base. They started at one location and they started to branch out to different locations in the country, and they simply add additional circuits. So each one of these blue lines here represents one point-to-point circuit. So there's 1, 2, 3, 4, 5, 6 circuits here. It's a simple network to manage, simple network to understand. There's one point of control right here. If I want to shut down the whole WAN for whatever reason, I can simply do that from the Toronto office. But this is not that secure physically. What's the problem, or what do you see as a potential problem with a WAN star topology? Anybody? Either turn on your mic and say something or type something in chat. Why do carriers oftentimes recommend that? Use that instead of a star topology for a WAN. Maybe if Toronto went out, that's one good point, Joel. If Toronto went away temporarily, power outage or whatever, you killed all of the connections to any of the other offices. Also, there's a couple of the other obvious reasons. Can you think of some other obvious reasons? Somebody else maybe. Why would I want to possibly do that, which costs more? Because there's how many blue lines? There's 1, 2, 3, 4, 5. There's 6 blue lines there. There's 1, 2, 3, 4, 5, 6, 7 blue lines here. One more dedicated circuit, another $1,000 a month. Why might I opt to do a ring architecture instead? No idea. What's the likelihood what's the likelihood of this connection? And bear in mind, this wire, there's not one single wire that's going, in this example, from Dallas to Toronto. This is a dozen different connections or more within the common carrier network that we don't necessarily have control over. Some of this might be wireless, some of it might be copper, some of it might be fiber, some of it might be going through very rural areas and very old telephone equipment. There's a lot of things that can happen in the 2,500 miles away that we are from Toronto. Farmer Ted, Missouri City, in Missouri here, not Missouri City, in Missouri, could cut a cable in the middle of a field, or physically something could happen that would chop that line there. And usually when dedicated lines go down, like if Farmer Ted chopped a line in half, they don't repair those things nearly as quickly because it's not affecting 10,000 customers, it's affecting one customer. So the longer the physical connection is, in this case, 2,500 miles. In this case, that's what is that from Vancouver to Toronto? What's that, like 3,000 miles through the frozen wasteland of northern Canada and southern Canada and northern United States? There's much more likely something's going to happen. So with a ring network, if it's a longer trek for the data. Dallas no longer has a direct link to Toronto, but again, this is layer 2, so we don't usually care that much. The frames have to go to Atlanta first, then to New York, then they'll get to Toronto. So it slows traffic down a little bit, but if this cable gets cut here by Farmer Ted in Missouri, in Mississippi now, Farmer Joe in Mississippi, the data can still get to Toronto, it just has to take the long way around. It's got 2 paths. So that's a more commonly recommended network. Star topology is the most common because it usually grows as a company grows, and it's cheaper. But there are issues with it, which we can mitigate by putting in a ring topology, which is the most commonly recommended WAN topology. But it is more complex. The disadvantages to this is you now have to have 2 devices in every city, or each one of your modems has to have dual WAN ports or dual ports on it to connect you in 2 different directions. and it costs more. It's a little bit more difficult to manage. There is no single point of failure with this though. So if your organization doesn't have a central site, which a lot of them don't, maybe that makes more sense. Now, if money was no object, again, each one of these lines, pretend each one of those lines is a $1,000 bill per month. Oh, and also here's another thing about dedicated services. It takes at least a month or more sometimes to get these things physically built out. Because a lot of times they, not only do they have to make changes internally within their networks, they have to maybe sometimes run some cable locally to you, to your building. There might be what's called a point of presence. Make sure you understand that term, POP, point of presence, for AT&T in Houston or in your area of Houston, but their point of presence may be an office that's a mile or two away from your building. And so you have to somehow get a cable from that building a mile or two away to you. If there aren't any physical cables available, they literally have to dig up the ground and run one to you or put one on poles. By the way, that is called the last mile. This is a term you need to know, or what's called the local loop. That's the physical cable that is installed from your local operation, whether it's in Dallas or Atlanta or New York, to the company's POP. We call it the last mile. It's not specifically 1 mile long. We just call it the last mile because that's the last leg to go before we get your data to you off of our WAN network, off our AT&T network or Comcast or whoever's providing that WAN to you. The old phone company term for it is called the local loop because it's the wires that are coming to your building are DC power wires, a positive and a negative. That makes a DC loop circuit. That's why they call it that, by the way. Now, what if all of these locations were super important? I needed to ensure that my network was operational all the time and that I had a lot of redundancy. You might opt to go with a mesh topology. This is an example of that, using that same organization with a full mesh network, a full mesh WAN, or you may opt for a partial mesh WAN. So if a ring topology isn't good enough for you, and the reason that this is not good is because if, for example, Dallas needed to send a message to Toronto or send data to Toronto and get it there as fast as it possibly could, I've got to go through 1, 2, 3 hops to get my data to Toronto, not just one. So the advantages to a star topology, assuming a WAN topology was secure, which it's not, there's only 1 hop from any one of these locations back to your main site. But the likelihood of something happening to these circuits makes it to where I might have to do that. Or if money were no object, again, each one of those blue lines is $1,000. If money were no object, you could opt for a mesh network, a mesh WAN, where every city, every location here is connected to every other location. So that's, that's 1, 2, 3, 4, 5. That's 6 WAN circuits times 1, 2, 3, 4, 5, 6, 7. That's 42 circuits right there. $42,000 a month just to provide you that network connection versus something like $6,000 a month or $7,000 a month in case of a ring. Now, the only organizations that I ever see do that kind of thing, a full mesh network, a full mesh WAN, are the carriers themselves, like AT&T or Comcast or Level 3, because they're carrying traffic for a bunch of other organizations piggybacked on top of their network. So they have to have this big mesh interstate network of roads. Think about our interstate system that's across the United States, I-10 and I-20 and I-69 and all these different interstates. And you can get from point A to point Z many different ways. So if one freeway is closed, you can get on another freeway. It might take longer, but you can get there. That's important to have that because we're carrying traffic for everybody. So some companies opt to use this partial mesh network where they choose the more important cities or the locations that have a greater need, either because there's more employees there, there's more data there, or they need to be more closely tied back to our central office. But even this is a little bit more expensive. So this is, star topology is probably the most common WAN topology. And it looks just like a topology for a backbone network. Most backbone topologies look like that. You don't typically see a mesh backbone because it's much less likely that something's going to happen in a mile or two of cable that you own that's at your company site, going through maybe 2 or 3 pieces of equipment versus going across 30 pieces of equipment. Okay, so I hope I talked that to death. The second most common is the ring network, and that's the one that's usually recommended first by carriers, or if you have mission critical stuff and site critical sites, you go for a full or a partial network. So here's the matrix real quick. A ring WAN, robust loss of any one circuit. The disadvantages are the long routes may increase latency to get data from point A to point Z. And a star network, it's very simple to manage that. It's the cheapest. Messages require only 1 or maybe 2 hops. If I needed to go from Houston back to Dallas, it would go Houston, then to Toronto, then to Dallas. Simple networking there. But it's susceptible to traffic problems. One site, especially like another thing that can happen is Toronto might get bogged down because it's having to handle all the traffic. Toronto might not go away, but maybe there's just, well, if Houston needs to send a whole bunch of data to Dallas, for example, but you got to send everything through Toronto, and Toronto's busy handling traffic for the rest of your company, you have a bottleneck there. So star topologies create a bottleneck. And also failure of the central site, which is what somebody else mentioned, that Joel mentioned, that can cause the whole network to go down. Mesh network, short routes, robust to circuit loss or overloaded circuits, but the major disadvantage is it's expensive. Most companies can't and won't afford to do that. So again, this is all layer 2. 2 popular network topologies, there's actually 3 that are available widely. There's T-carrier service, which we don't see too much anymore. The most common type of circuit you order is called a T1. There's another one called a T3 circuit. These are not very fast circuits. And then we have the newer SONET circuit service. And then now we have something called Metro Ethernet, which is using Ethernet frames, but on a wide area network connection. So T-carrier service. Hopefully none of you in here will have to deal with T-carrier service, but you might if you're in a developing country or you've inherited a legacy site where maybe there's a company site that was set up 30 or 40 years ago and they don't have a great need on their land. Or actually, I'll tell you where T-carrier service still is used in very commonly is ATM machines. In the banking industry, I know a lot of you guys do banking online, you do banking over the internet, but bank-to-bank transfers. If a bank wants to send $1 million to another bank, they don't use Zelle and they don't use bill pays and they don't transfer money like that over the internet. That's much too insecure and the FDIC doesn't allow it. They have to use layer 2 networks. So all banks have to have, whether it's a WAN connection or internet connection, they have to have a dedicated circuit service connection. Sometimes it's a T-carrier service if it's not a very busy bank, or if it's just an ATM machine. There's a lot of standalone ATM machines out there, but they're only in very few cases are they allowed to be wireless or running on the quote-unquote internet. Yes, they do have wireless ATM machines or standalone ATM machines, but they probably have a T1 or a fractional T1 going to them. Or if they are cellular, which they do have some of those, the maximum amount of money you can get out of them is like $100 or $200. So T1, This was the first service that was available in the United States. It's only 1.5 megabits per second. It's 1.544. It's actually 24, quantity 24, 64K, 64K channels that are bonded together, 64 kilobits that are bonded together. So what's 24 times 64 kilobits? Approximately 1.544 megabits. That's how we get that number. Seems a little arbitrary. Why 24? And you guys probably don't know the answer to this. It's probably not that important for you. But the reason it's 24 is because back in the old days of AT&T running cabling to buildings for commercial usage, they would run what's called a 25 pair cable, which is a big thick cable with 25 pairs of wires in it. T1 carrier service said, hey, let's use one of those pairs for the control pair, or the pair that turns the circuit on and off, and let's use the other 24 pairs of wires, so that's 50 wires, to carry 64 kilobits per second of digital data on it. Let's bond those together because we've got 24 pairs of them, and we get 1.544 megabits per second. Now, that doesn't sound like very much speed, does it? And it's not, compared to the fact that we can order gigabit per second shared internet service, but it's shared. T1 and T3 were the only thing that were ever available, although there are specifications for T2 and T4. It was never available in the United States. So your company either ordered a T1, this is like 25 or more years ago, before the internet was a thing. If you wanted to connect Houston and Dallas together, your only options for high-speed circuits was either you got a T1 or a T3. My first T1 that I installed between two locations just in Houston was $2,600 a month. Super expensive. This is back in the late 80s. T3s were like $8,000 a month. They're much more expensive. A T3 is basically 28 T1s. So that times 28 gets you 44. 40, we just rounded off to 45 megabits per second. So the only two speeds for WANs way back then were 1.5 megabits or 45 megabit. On copper wire, that's what the T stands for. This T stands for telecom or telephone. We're using telephone wire to carry internet services. Similar to DSL, which some of you know what that is. Now in Europe, they have e-carrier service. It's 2 megabit per second. And that's because the common wiring scheme in Europe was to use 30 pair. It was actually 32 pair wire cable. So they brought 32 pairs of cabling to Europe. So actually Europe was a little bit ahead of us only because their infrastructure was newer. All of this stuff started in the United States first, and then it went into the rest of the world. So that's one good thing about newer technology in developing countries is the developing countries don't have to deal with legacy equipment that they have to replace. It's all new for them. Okay, how are we doing on time? We're all right on time. Now, with the advent of fiber optics, this is much more common now for WAN services. Most companies are not using T-carrier service unless they're a small bank or an ATM or it's a legacy situation. New installations. If I'm in Amazon.com, for example, and I need to connect my Houston office back to my San Jose office or wherever they are on the West Coast, I might opt for optical carrier service, which AT&T provides, Level 3 provides. Some other organizations provide this. OC service, it uses fiber optic wiring. That's the only way you can get it. That's what the OC stands for. Its slowest available rate is 52 megabits. It's 51.8, but we rounded up to 52. So OC1 is 52 megabits per second. That's faster than the fastest T3 service. Also, these days, T3 service costs about to go from point to point, Houston to Dallas, for example, probably costs you about $1,200 a month. To go from Houston to Dallas with OC1, about $1,000 a month. So it's comparable in price. It's not available everywhere, so sometimes you still have to use T carrier service, but in most big cities, we can get OC service. So 52 megabits per second. Got to use fiber optic wiring, so new wire typically has to be run to your building if there's not already fiber optic wiring to your building. So it's not available in every area, although most new buildings that are being built, if anybody's driven down the Beltway lately in the Stafford, Missouri City area, they're building a whole bunch of new warehouses out there, or down Highway 90. AT&T and Xfinity, or Comcast, I should say, and Phonoscope, they're all running fiber optic wiring to those buildings even before they're occupied, because they know that they're going to get some big users in there. So there's actually OC 1, 2, 3, 4, 5, 6, 7. These are how you order this. OC1, OC3, OC192, 10 gigabits per second. An OC192 line, you can go up to OC768, by the way. That's like 400 gigabits per second, but it's very expensive. You're talking about $40,000, $50,000 a month. So this is, although that doesn't seem, maybe 10 gigabits doesn't seem that fast to you, it's pretty fast. It's 10 times faster than the fastest home network you can get right now. You can get gigabit Ethernet through Comcast, but that costs what, a couple hundred, $250 a month? That's going to cost $10,000 a month. Quite a bit more expensive. So keep this in mind. OC service differs from T carrier service because it uses fiber optics end to end. Not the same fiber optic cable, but it uses fiber optics end to end. That's the only way it can carry that much traffic. The slowest OC1 service that's available, 52 megabits per second, is faster than the fastest available T carrier service, which is called a T3, which uses copper. And then there are wireless WAN services as well. The wireless services, by the way, I'm gonna go ahead and skip packet switch networks because they're just not that common anymore. So I'm gonna skip this. I will talk about this, committed information rate versus maximum rate. When you order T carrier service or OC service or internet service for that matter, your service provider may give you, if you pay for it, what's called a service level agreement, not just necessarily for uptime, but for information rates, committed information rate versus maximum allowable rate. You might opt to get a OC1 circuit, but it might be actually a shared circuit where they're actually piggybacking other data, not between you and the point of presence, but let's say you have an office in Houston and an office in Dallas. You have a local loop that's dedicated in Houston and a local loop that's dedicated in Dallas, but then they're putting you on a shared network between Houston and Dallas. So there's traffic from other companies on there. It's at layer 2, so the security's there, but the speed may depend on the amount of traffic the other company's putting it through. You might opt for that service because it's going to cost less. They'll give you a lower price tag. It's like they're giving you a toll, they're giving you a pass to a toll road, which a limited amount of other companies use, versus building your own freeway or giving you a toll road that only your company's using. That's called a packet switch service, and they do have that on fiber optic services. They give you a committed rate. So you might say, I want an OC1 packet switch. They'll say, okay, your maximum allowable rate, assuming nobody else is using that network, is 52 megabits per second. We will commit to 5 megabits per second, just as an example. So you'll get at least 5 on a super busy day when people are uploading and downloading and doing backups. You might go down to as low as 5, but you can burst up to, they call it bursting, you can burst up to the 52 megabits per second. So make sure you know those two terms, committed information rate versus maximum allowable rate. And I suppose you really do need to know what packet switched networking is. And that's basically just where, notice it's not frame, it's packet. your frames are actually getting turned into packets and carried over that carrier's layer 3 network, then turned back into layer 2 at the other side. So it starts out as layer 2 traffic in Houston, goes to AT&T's local point of presence there, gets turned into layer 3, goes over their packet network as a packet, an IP packet, then gets turned back into a frame at the other side and dropped back onto the Dallas network. Okay. What an example of the topology looks essentially the same. You can get them in star or ring or mesh. The difference is you're paying less money per month, but it's a shared network. Okay. So don't think of it like a bus that you're getting on. You can think of shared internet as you're getting on a bus and your packets are getting on a bus, and it's common, and everybody's packets can potentially be seen by everybody else. A dedicated network is you're leasing a toll road from an organization and you're the only one allowed to use that toll road. And a packet switch service is you're leasing a toll road, but other people are also using that same toll road, but you're all high-level users. So Comcast and Level 3 offer Ethernet. So instead of using PPP, point-to-point protocol, they offer Ethernet or this newer protocol called MPLS. So it's, and they advertise Ethernet as a better protocol to use. Comcast says, hey, we can give you a layer 2 connection from Houston to Dallas or Houston to Toronto, and your Ethernet frames stay Ethernet frames from end to end. They don't change. The advantage to that is there's less protocol switching, so your layer 2 network runs faster. Okay, if we don't need to change protocols from Ethernet up to IP, then back down to Ethernet, it's supposedly faster. The higher up we go in the hierarchy of the internet model, with our information, with our data, the slower things get. Don't worry about that frame. By the way, the term for the common carriers network that they use is called the PSTN. Make sure you remember that terminology. It's not as commonly used anymore, but it's PSTN. We usually refer to that term PSTN when we're talking about phone numbers. In other words, if a technician was to ask you, what's your PSTN address? They're asking you what your company's main phone number is. Publicly switched telephone network, PSTN. By the way, what's the opposite of a PSTN? What's a private telephone network called? Anybody know? Do you know, Rahi? It's called a PBX. Private branch exchange. I can't type today. Private branch exchange. That's important for you guys to know as well, too, because a lot of your networking management function will probably involve also managing one or more PBXs on your local network, or maybe a separate PBX network, but a lot of times they're shared, right? Exactly, like asterisk servers. In other words, VoIP. We're carrying voice traffic over our networks to a PBX server, or servers or PBX equipment. So you do need to know what these terms are. That's why I'm throwing them out at you, because so much of networking these days involves VoIP and involves video, which is what we're doing right now. Okay, you don't need to worry about the actual, this is not that important for you guys to know. Just understand that there is, just like an Ethernet frame, there is a from and a to address and some user data in there, your layer 3, layer 4, and layer 5 traffic. Now, most companies are moving away, small to medium-sized companies are actually not using dedicated services as much as they used to anymore. they're opting to take it up to the next level, to take it to the layer 3 IP level. There's pros and cons to that. The pros to taking it up to layer 3 for your networking. This is where VPN comes into. If you take your networking WAN needs up to layer 3. So if we go back to this, let's take this company's example here. So I've got this many connections in this many cities, and Toronto is my home base. If I wanted to set up a quick and dirty WAN network, what I could do is I could just tell each network manager in each one of these cities, hey, sign up for an internet connection with whoever the prevailing carrier is, whether it's Time Warner or Cox or Comcast or AT&T or whoever it is, whoever gives you the best deal and the best speed and the best reliability. Sign up for them, get a set of local IP numbers, and connect yourself to the internet. We'll do the same thing here. So this topology here in a IP network, a layer 3 network, the topology logically can still look like that, but we're putting everything up at layer 3, and our traffic is traveling through different carriers. It may be coming out of Time Warner. They're the prevailing cable carrier in Dallas, and they may be using Comcast in Atlanta. Different carriers, which is allowed because it's IP traffic. We can't do that with layer 2 traffic. If we want to set up a layer 2 dedicated network, typically it either has to be with the same carrier. In other words, AT&T or Comcast or whoever you use has to have POPs, points of presence, in every single one of these cities, or they have to have a carrier agreement with another carrier that agrees to hand off layer 2 traffic. In other words, they have a WAN connection dedicated between each other. But it's much cheaper, much faster to get set up. As you guys all know, your home connections, those are basically, they're all layer 3. You got an IP address, and you're paying, some of you are paying as cheap as 30 or 40 bucks a month for an internet connection, or maybe your parents are paying it or somebody else is paying it. Most of you are not paying, I don't think anybody here is probably paying 200 bucks a month for an internet connection. If you are, you're getting ripped off. Commercial internet connection service is anywhere from 60 to 300 bucks for like gigabit speed. That's much less expensive than $1,000 a month or 10,000 bucks a month. So a lot of companies opt to do that instead, where they're using layer 3 IP traffic. Now, what are the disadvantages? Let's get back to here. If I take my traffic up to layer 3 as opposed to layer 2, what are the disadvantages of using layer 3 traffic? There are several. What did I say just a few minutes ago about anytime you have to pass traffic up higher in your internet model, there's more overhead, so it slows things down. So layer 3 networks are slower because it takes more to get traffic from point A to point B. Also, if it's IP traffic and I'm using XYZ brand of internet service provider, there's no security. And I'm not just talking about hacker and cybersecurity. I'm talking about it's too variable. AT&T might be really good in Dallas and might suck real bad in Houston, which is the case. So if I opted, or if I told all my network managers, we're going to use AT&T's network because we like it. Well, if AT&T in the Houston area is not reliable, my Houston office is going to go down all the time. So you have the flexibility, but you're trading the flexibility for security, either in terms of availability or the cybersecurity thing. You can't really hack a layer 2 network. The only way to hack into a layer 2 network is to literally jack into it, or if it's a wireless network, get into the wireless connection, because that's layer 2. To get into a layer 3 network, all you have to have is the IP addresses in an internet connection. That's all you got to have. So it's not very secure. That's why VPN was invented? Virtual private network, VPN. Very common stuff. Does anybody in here use VPN for any reason right now? What's called Road Warrior VPN. Or single user VPN. I'm sure Rahi does. So virtual private networking. How many people have heard of VPN? You can just say yes or type in something. You've used one. So let's talk about that for a minute, Joel. So you've used one to watch Netflix from another country. You've heard of it. So Joel, why did you use it for Netflix? Why did you have to use VPN? And for those of you that don't know this, there is some content on Netflix which is available in other countries, but not here, or vice versa. A movie that was released in the movie theaters might already be available in Iceland or Germany or another country, but not here because they're still showing in the movie theaters or there's still rights to it. So there was a movie that you wanted to watch, but when you got on the internet, your IP address, your public IP address that you were getting, was flagged as an IP address in the United States. So Netflix said, sorry, this content's not available. Or it didn't even pop up on your menu to be able to watch. But if you download a VPN program and you subscribe to a VPN service, all of your IP traffic is tunneled. And I'll show you here, I'll just skip to it now. All of your traffic, let's say this is Joel's office here, or Joel's home here, and let's say this is a provider in, what country was it, Joel? Do you recall? Or was it random? A lot of them you can subscribe to these services and choose which country you want to be from that day. You can say, well, I want to look like I'm from Spain today. And so what'll happen is a virtual tunnel is set up. You have to run special software either on your computer or the router that's connecting you to the internet has that special software into it. That special software up at the application layer, higher up, logs into another server or another router somewhere else, establishes an IP connection. Then your data link layer traffic or your IP traffic doesn't go out onto the internet, or does go out onto the internet, but it gets encapsulated, sent to this other organization, and then they put their IP address on it, and then they send that request out onto the internet. I think you can't use VPN for Netflix in some countries. Well, that's because they tried, what they're doing, Colette, is they're cracking down because there are specific VPN companies like Aloha VPN, for example. I used to use Aloha a lot because I liked to watch BBC TV. Anybody from the UK in here? For those of you that don't know, and this is true for other countries as well, in this country, we have what's called public broadcast television. I'm not talking about Channel 8. I'm talking about the television that you can turn a standard TV on that has rabbit ears and pull television signals out of the air and watch it for free because it's commercial based. You're watching commercials and you're buying their toilet paper or whatever it is they're selling. Well, the BBC in the UK doesn't work that way. Yeah, they do commercials, but it's more of like 10 minutes of commercials once an hour. It's not commercial based television. You pay for your TV in taxes. When you go buy a television in the UK, you pay a lot more money because you're paying an upfront tax to use that TV, presumably for the life of the TV. So TV that might cost $300 in the United States cost $1,000 in the UK because you're paying the TV tax. And then you can watch, but because you're paying for that, you're allowed to watch BBC television over the internet because they don't really care how you get it as long as you get it. As long as your taxes are paying for it, you should get it. So you can log into bbc.uk and watch it if you're from an IP address which is located in the UK. So these companies like Aloha VPN, you go Google for that if you want. There's literally hundreds of these companies. They pop up all the time. They'll say, we'll set up a VPN network so that all of your traffic comes off of your network. It's in tunnel, encapsulated. It comes to our network first. Then we strip off your public IP address. We put on our own, kind of like the way network address translation works. And then we put that request out onto the internet to Netflix or whatever it is. Netflix thinks you're coming from this company's public IP address. So they connect you up, and then they take your traffic and they send it back to you. It's called proxy networking. That's another term for it as well. Network by proxy. Similar to the way network address translation works. So VPN network, that's what VPN networking is used for when you have an organization that's trying to hide where their physical point of presence is. Most hackers are using some VPN service. They're usually using a hacked VPN account to make it look like they are in Estonia or Poland or Canada or wherever else they are. A lot of hackers and a lot of the hacking traffic, and a lot of people say, oh, there's all this hacking coming from China or coming from Poland. That may be true, but a lot of the hacking that looks like it's coming from there is really coming from here because they're using VPN tunnels to essentially hide where they are from. Yeah. So, yeah, what is Seedbox? I don't know what Seedbox is. Is Seedbox a hacking program? That's okay. Maybe I don't want to know what Seedbox is. So anyway, for commercial applications, and it's not just all about hacking and hiding. For commercial applications, this is absolutely necessary. If this is critical data that you're now putting on the internet, anytime you see a big cloud like this, it says the internet, that equals danger, danger, danger. The internet is like, you're going to put your grandma in an old beat up car or a Jeep that doesn't have it doesn't have any windows or doors on it. You're going to say, hey, grandma, go drive your Jeep on the Autobahn in Germany and you go as fast as you want. Well, I don't drive that fast. Yeah, well, there's other people going 300 miles per hour on the Autobahn. It's very dangerous. So you need to protect your traffic is the point. So if you opt for an IP-based network, in other words, you just tell all the locations, go get whatever internet provider is prevailing in your area. In other words, it's not a point-to-point connection. It's just an internet connection. Then on top of that, you have special software or special routers, or the VPN is built into your router or your modem that establishes a link at a higher layer, at a higher layer, encrypts it, puts it on the internet, and then decrypts it on the other side. It's the only way that you can really ensure any sort of security. There's different kinds of VPNs. There's an intranet VPN. This provides what's called a virtual circuit between organization locations over the internet. This is the most common, an intranet. An extranet VPN, this is very similar to an intranet, except that the VPN connects different organizations over the internet. So doctors' offices, for example, connect to hospitals, or insurance companies connect to each other via VPN because they have to share very sensitive patient data, which is not allowed to go unencrypted over the internet. So they have to use some sort of dedicated circuit service network, either a dedicated layer 2 network, which nobody does because that's too expensive. When I first started the medical billing business years ago, I had to either use a telephone line and a modem, or I had to get a T1 to Blue Shield in Dallas to send claims. It's very expensive. So when they started allowing this, they said, yes, you can use a VPN service. It was much, much cheaper. But that was called an extranet. And the only difference between these two is using the same hardware, same protocols, same technology and topologies. It's just that we're not related to each other, or we're loosely related because we're in the same business, but we're not the same company. And then the thing that Joel and other people were saying that they use to watch TV in the UK or wherever else, that's called an access VPN. where you're using it. And some of you might be using it right now. If you guys are working from home and you're working for a company that has high security or any sort of security desire at all, they're having you use either OpenVPN or Cisco VPN. This is the most common one. It's called OpenVPN. You can go Google for that. Go Google for what OpenVPN is and make sure you know what OpenVPN is. It's open source VPN software that you can download and run on your Windows or Apple or even on your Android, which will encapsulate and encrypt all your traffic, and you connect to another VPN site somewhere else, either your company's VPN. So we have it at U of H. I can connect my laptop to U of H's internal network so that it looks like I'm on the 129.7. whatever network, but I'm here at home. That's what they want us to use to maintain that security. Also, I can have access to all of the things at my office that are internal, like printers or copiers or cameras or whatever else I normally had access to internally. So is anybody in here that you know of using a VPN right now to communicate with your company that you're working for? I know Rahi said he was using, you set up OpenVPN so that you could talk to your server in the EI lab there. It's a good thing you did do that, isn't it? Otherwise you wouldn't be talking to it right now. Some of you are using Cisco VPN. Cisco has this thing called Cisco AnyConnect. I can't spell today. AnyConnect. That's their version of VPN software. So you either do it with a router on your network that does the VPNing for everybody, or you run software specifically on your PC, and it depends on your setup. In the cases, and the reason we call Access VPN a Road Warrior VPN is the Road Warriors, those are your salespeople, those are your management people that are out in the airports all the time or on the road all the time, and they need access to their sensitive data inside their company's network. Well, you don't want to be accessing your company's network across an airport network without some sort of privacy going on. So that's why we use VPN. So make sure you know these different terms, and you know the terminology of encapsulation and tunneling. So this is more specifically what's going on. We are taking Ethernet frames here, encapsulating them into IP layer 3. In other words, we're taking layer 2 traffic, bringing it up to layer 3, and then we're tunneling it across the internet. And the reason it looks like conceptually a tunnel is because we've encrypted it, so nobody else can see what's in that data. We don't know if it's video data, voice data. We don't know what it is. It's something. It could be Netflix. We don't know what it is. And then it gets decrypted and decapsulated and turned back into layer 2 on the other side. So it looks to the applications like it's a layer 2 network going on. It looks to the hardware like there's layer 2 going on. When you set up a VPN connection in OpenVPN, it looks like you literally have 2 Ethernet connections. You have your wireless connection, then you have this second Ethernet virtual card which pops up in your network settings, and you can pass traffic through one or the other. You can do what's called split VPN. So if you just surf in the net regularly, you have your public IP address still, or you have the IP address on your router, 192.168, whatever. Then you have this other IP address, which is like a third IP address. It's not yours, it's one that you're being loaned by your VPN router or the VPN software, specifically to speak through that tunnel, not around it. Because this computer could very well talk to that computer there outside of the tunnel through other applications like instant messaging or whatever. But if you wanted to access data off of a hard drive, you should be referencing the IP address that refers to that tunnel. Okay, so I recommend everybody do some sort of experimentation. Since we really can't do the EI labs like I wanted to, what I'll probably do is figure out how to, and maybe Rahi can help me with this. You've got an open VPN server set up. I'll set up VPN on some additional servers I have in the EI lab there. See if we can get you guys to install Open VPN. So if you have not already downloaded, might as well go download it now. You don't have to know how to use it right now. Just go download it, get it installed. Then I'll send you guys some information on using Open VPN so that you can see what it does literally to your laptop or your Mac or your Android. And you can see how you can pass traffic between two different networks, a private network and the public internet. What are the disadvantages to VPN? So obvious advantages are it's inexpensive, instantaneous in a lot of cases, and flexible. If you don't have it, you don't have to, like I said before, a dedicated network connection takes literally weeks or sometimes months to build. But with a VPN, all I have to have is any internet connection, whether it's wireless or a local internet, or I'm borrowing somebody's internet from the business next door. But yeah, the difference is it is slow. Because why is it slow, Rahi? Because of that right there, because internet traffic is unpredictable. It's a totally shared network. Like I said, it's like putting grandma out there, not even in a car, it's just putting grandma out there on her walker, saying, okay, there's the world, go play in it. Or VPN would be the equivalent of putting grandma in a tank before you put her out on the internet. So yes, that's correct, Joel. A VPN is not using a dedicated physical circuit. It's using a dedicated logical circuit. You set up a dedicated logical circuit between you and a VPN provider or your home office, and it requires something like a username and a password. You have to have something that identifies one location to the other. Usually, like I said, it's a username and a password, or a key, or a special file that you download and store on your computer, as in the case of OpenVPN. Okay, so just want you guys to understand the difference between using true dedicated networking at layer 2 and using VPN up at layer 3 and higher. You can achieve the same thing. And VPN actually is very secure. It's very difficult to crack VPN. Dedicated circuit is the most secure because, like I said, the only way into a layer 2 network, if it's all wired, is physically jacking into it. With a VPN network, it is less secure because with the right credentials, if I know somebody's username and password on a VPN network, I can get into it. But the actual data flowing across the internet is very well encrypted and literally impossible to decrypt. You can turn on such high level of encryption that it would take literally a supercomputer months to try to crack the algorithms that are being used if you're using like 4096-bit encryption. But it's unpredictable. Here's another disadvantage. There is several different implementations. Cisco does their own thing. Juniper does their own thing. Amazon has their own kind of VPN. Oracle has their own VPN. There's OpenVPN, which is a generic VPN, but there's about 10 or 12 different ways that you can encrypt the data and about 20 different parameters on that, whether you're using 256-bit encryption or 512 or 2064. Are you using Diffie-Hellman encryption? What are you using? SHA encryption? There's a bunch of different encryption protocols. These are all layer 5. They're not really networking protocols. They're layer 5. They're application layer protocols because they're taking your actual data, not your ones and zeros, but your A's, B's, and C's, and converting those into X, Y's, and Z's. And they can be incompatible. And it's sometimes a real pain in the ass, and Rahi can probably attest to this. It's a pain in the ass to get a VPN network working reliably and set up properly, especially if you're not the one that set up both ends. You're a network manager and you set up the home office like you want it to be set up, and then you send out emails to all of your stupid employees that aren't network managers. Say, okay, here's the username and password, and make sure you say that it's you know, SHA encryption number 256 and enter all these other little parameters you're going to have. And yeah, DNS is an issue. So it is difficult to manage that. So traffic is unpredictable, difficult to manage, but in temporary situations like we have right now, it's very powerful and very flexible. Also, the fact that everybody's internet connections are getting faster. You know, Comcast and Xfinity, they're all working on getting their AT&T, they're all working on getting their networks faster. Or some of you might be on 4G or 5G even. Okay, so in WAN best practices here, we're almost done. T-carrier services. Data rates are only up to 45 megabits per second. That's the fastest possible data rate. Relative cost is moderate, low to moderate. Reliability, very high. T-carrier service reliability has been around for many, many years, so it's very robust and it's well understood. There's very few options anymore. SONET service costs more, requires fiber. You can get actually now up to, like I said, 100 gigabit per second connection with OC 768. That's actually 622 gigabits per second. Very fast. High reliability because it's fiber. Also, there's very few organizations using it. Disadvantages to it, other than it's expensive, is it's not available everywhere. Most companies are going to have hybrids of all of this. They're going to have some SONET service, some T-carrier service, some VPN. Most companies are going to have some hybrids. Packet switch service like Frame Relay or Ethernet or MPLS, they cost less money. The reliability is still very high because all of these are still layer 2. When we get down to VPN, that's layer 3. Cost is very low. Reliability, it used to be low, but now it's getting moderate. We've changed that to moderate because, oh yeah, and you have data caps too. That's on your home service, by the way, Rahi. Businesses don't typically have data caps on their connections, but they cost more. Reliability is moderate, or actually what that should say there is reliability is unpredictable. It totally depends on what your neighbors are doing or where you are when you're trying to use that VPN. Are you at Starbucks? Are you at home? Are you at an airport? And you know, what time of day is it? Is it the middle of the day where lots of people are using it, or is it 3 in the morning? Are you on a cruise ship trying to use it where there's 3,000 people using a satellite connection in the middle of the ocean? Yep. All true things. This will all be part of the video, the things that are Rahi are typing. Rahi's had a lot more experience with this kind of stuff than a lot of you have, so, or at least he's done a lot more research on it. And that's because he's old like me, maybe not as old as me, but you've been around long enough, you learn this stuff, you get experience, you get exposed to this stuff. You're using this stuff for your own business purposes. A lot of the stuff I talk about, this is all new to a lot of you, but as soon as you start working in the industry, whether you're a low-level tech or you're a high-level manager, you're going to be exposed to all of this stuff. So in your network needs, and if it's low to moderate traffic needs, VPN. If reliability is less important, use VPN. If you have very high traffic needs, you need to offer something like Ethernet or MPLS service or SONET if it's available. In WAN design practices, also in terms of improving WANs, here's the 3 things to look at. Change the devices out. The devices are, a lot of times when you set up these WAN routers, their processors can actually be upgraded because basically these are just computers. You buy faster processor devices, or you add more memory. I've got a WAN device that I use to connect me to the internet at my data center. It started to slow down. I was able to add more memory to it and sped it up. So you can either only change your devices out, change your circuits out, or change the demand. Pretty easy to change the devices out or upgrade the devices. What's that? No, I don't use pfSense. I use DDWRT. Or you change the circuits, which is sometimes very expensive or takes months to do. That's why a lot of times, like for example, a Kroger recently opened near me, and Kroger has very high volume of traffic. They did not have internet service. They were using a 4G network on a cellular service with VPN because that's all they could get at the time because they had to wait for those circuits to be installed. Yes, I use Sophos for commercial applications. I use Sophos. And Sophos uses OpenVPN, by the way. You can actually download VPN directly out, OpenVPN from a Sophos router. It's pretty cool stuff. Or you can change the demand. The same things that we do on LANs to change the demand, we can do on a backbone or a WAN network. We move files physically closer, static files, physically closer to our employees, for example. Or we don't do our backups in the middle of the night. I mean, we do our backups in the middle of the night, or we do them when people aren't using them. So these WAN performance improvements are the very same thing that we've already talked about on how to improve LAN performance and backbone performance. That's pretty much it for that chapter. And we're pretty much at the end of the class. So in terms of the future or what's going on right now, there is a shift away from T-carrier service, mostly because it's very legacy. It's not fast enough for our needs anymore, to either SONET service if it's available, or straight Ethernet. Comcast, which is the business version of Xfinity, is a big pusher of Ethernet. They call it Metro Ethernet. That's their flavor of it. Metro Ethernet. If you call up Comcast and say, hey, I want to connect up my Houston and my Dallas office together, what you got? Let's say, well, we got this Metro Ethernet service. You can get 10 megabit or 20 megabit or 50 megabit or whatever speed you want. It looks physically like an internet connection. They bring you a cable to your office or they bring fiber to your office, but it's dedicated. You get a dedicated circuit number and it's your freeway. It's your lane on your freeway to use. It's like, I guess rather than saying it's like a toll road, it's a multi-lane freeway, but you get your own company's lane that nobody else can be in. That's probably a better way to look at that. Cost of WAN hardware and services is decreasing. Like I said, my first T1 was $2,600 a month. They're much cheaper. They're more like $800 a month now. And usually we don't do point-to-point anymore. We do point-to-internet. We do single point, and then we use either IP services outright, just IP to IP, and do everything at layer 3, or if we need security, we do VPN on top of that. Because our speeds are getting faster, the slowdown of VPN, the unpredictability of VPN is not as bad anymore. And again, similar to LANs and backbone networks, WANs are experiencing standardization and commoditization, where there's fewer and fewer LAN protocols, WAN protocols. And companies are now connecting their WANs together so that AT&T and Comcast can provide local internet dedicated services for the last mile, and they can share layer 2 or dedicated traffic within their networks at what's called MDFs, by the way. I didn't talk about that yet, or I've talked about that in previous class, but make sure you know what an MDF is. I'm sorry, not an MDF, an IXP. That's where internet provider, I've talked about that in previous class. That's where internet providers come together to connect their networks together. Some of them connect at layer 3, some of them connect at layer 2 and layer 3. At inter-exchange points. The major inter-exchange points in our country are in the major cities that are usually in the middle of the country. Not Houston. We're not a major IXP. Dallas is. Las Vegas is, and that's because they're a major data center now. Okay, so if there's not any more questions, I'm going to go ahead and end or there's not any questions. You want to make any more comments, Rahi, since you're doing such a great job? Okay, you're good. How about anybody else? Okay, so that's it for the Chapter 9 lecture. Like I said, I'm going to do a Chapter 8 lecture. I started to get into Chapter 8 in this class, but I want to do just a Chapter 8 lecture that doesn't also have the subnetting in it. The subnetting lecture that I published and posted, by the way, was from the 4 to 5:30 class because it was pretty much just subnetting for the whole class. So you guys are all welcome to look at that video. It is not published, excuse me, it's not publicly advertised on YouTube. You got to go to the link. So I believe you guys all have the link to go to it. If you can't find that on Blackboard in the announcements, send me an email and I'll make sure that you have the link for the subnetting assignment. So your marching orders for right now are to get those subnetting assignments done. If you have any questions on exam 1, send me those questions. 2 or 3 of you did, not too good. Most of you did really well, but a couple of you didn't do that well. If you have any outstanding grading issues, let me know about those. Get the subnetting submitted, and then I will get chapter 8 published on YouTube, and then I'll let you know probably tomorrow when oh, you did it again. Good. I'm glad. Yeah, you can submit that thing up to 5 times, the electronic version. I'll have the exam 2 available for you guys to take probably by the Wednesday class. So like Wednesday I'll probably make it available like Wednesday through Saturday evening to take, Saturday at midnight. And like I said, the exam 2 study guide from previous semesters is already there. I don't change much on exam 2. The biggest part of it is the subnetting. So make sure you guys have that down well. All right. I will see you guys. I will talk to you guys on Wednesday, normal class time, 2:30 to 4:30. No, 2:30 to 4, excuse me. Bye-bye.